Hello everyone, welcome in my very first video on YouTube, and in this video I am going to show you how you can implement the logistic regression in Python. Moreover, I am using Indian liver dataset for building this model. So let's understand what is logistic regression and why we are using it. The logistic regression is a statistical analysis method to predict the binary outcome such as yes or no. In the simple words, we can use it when the prediction results in is in yes or no format, and if your variables is continuous, then you should go for the linear regression. The basic difference between the logistic and linear regression is logistic regression generates limited output, and as I told, while linear regression generates infinite outputs. I am using logistic regression because my output will come in yes or no format, just like a presence or absence of the liver disease. So I hope everyone understands what is the logistic regression, and now I am moving on the implementation part. So here I am started with importing Python libraries pandas, seaborn, plotly, matplotlib. We are using these libraries for the data pre-processing and visualization. Then here I am creating data frame df and importing CSV file of Indian liver disease patients. With df.5 function we can fetch we are fetching the first 5 rows of our data frame df, and here you can see guys, we have plenty of information and factors that affect the liver directly, such as total number of proteins, albumin and globin ratio, age, gender, patient, and many other factors. Okay, now I want to check how many rows in our data frame. So df.information function, I can check the information of our data set. So there are 583 total rows, or the number of patients which is available in this data set. If I closely look at here, the column dataset having two values in one or two manner. So the one here indicates that the patient have disease, and the two indicates that there is no or absence of the disease. So I am changing this column name to diseases because it's our target variable, and we have to finding the predictions of diseases. I use the pandas rename function over here. After that, checking null values is the most important part or the step while building any machine learning model, and you can see here there are 4 null values in albumin and globin ratio. So there are different ways to handle null values, like you can drop it, or drop it with the pandas na function, or the replace it with the mean values, and many others, such as replacing null values with the k-means clustering. I am using mean method and going to replace the null values with the mean. So finding the mean of this column, and it's 0.94. Okay, now I am replacing null values with 0.94, and that's it guys. The pre-processing part is almost done, and now I am moving on the visualization part. So firstly I am plotting all columns to the plot histogram, and you can see the number of histograms such as gender, age, alkaline phosphate, and many more. Later, using the pair plot function, we can find the relationship between the columns, such as the multiple columns. Okay, now I'm using the plotty to plot pie chart of gender column, and here you can see there are 24% of females in our data set, and the rest of them are the males. Same bar plot of the age group with the Seaborn library, and you can do more visualization stuff, but I am stopping here right now and moving toward the building the machine learning model. And I am applying the lambda function to convert our string male or female values in the integer format, because any machine learning model does not accept string characteristics. So I am giving male as the 1 or else 0, which means all the male values in the gender column will converted into 1, and the rest of them which is female will convert it into 0. Now I am separating now I am separating the dependent and independent variable into new data frames, creating X for the independent variables which factors that affect on the liver, and our target variable is the probability of disease, so the Y data frame assigning for it. With this line I am creating the variables and separating our data set in 70-30 manner. Here you can see I am giving the test site 0.30. Later we will compare our train model results with this 30% of the test data, and I am giving the random state 123 for the reproducibility. Now I am importing the logistic regression using Skyline library and I am also importing the confusion matrix. Here I am fitting the X train and Y train values, and that's it guys. We created our logistic regression model successfully. Now I only want to check the accuracy of our model, and so here I am calling the accuracy score, recall score, and the precision score as well. So after that you can see the accuracy of the model is around 0.73, which means the accuracy of our model is 73%, and the recall is around 93%, which recall describes the number of true positives and the false negatives. After that, calling the confusion matrix, here you can see the confusion matrix array object, and the dimension of the matrix is 2 cross 2, because this is the binary classification, that's why it's 2 cross 2. And here this is the diagonal value, and here these diagonal values represents the prediction. So 118 and 10 are the actual predictions of the liver disease. So let's visualize the results of confusion matrix in a form of heat map by using the Seaborn and Matplotlib, and here it is. So alright guys, we are successfully implemented the logistic regression on a liver disease database with the 73% of accuracy, which is really good. And I hope you like this video. I am providing the data set in the link in the description. Thanks.